Hello, my name is Nagasai Pillai and today I am going to talk about Doppler using Doppler frequency to find the speed of a target. We have to know before going on to the topic, we have to know what is a Doppler shift. A frequency shift that occurs in an electromagnetic wave due to the motion of scattering towards or away from the observer. Here the analogy is the sound waves and the Doppler radar that can determine the frequency shift through the measurement of the phase changes that occurs in electromagnetic waves during series of pulses. The electromagnetic field is this thing, and here we have written the electromagnetic field in this time, and the time it took is this is the time, and the substituting the equation of delta t to this equation, then we will get the frequency received from the with the frequency derivatives is f1 ft f1 dc or dt is equal to 0, and this is how. And the simple convention is that we are going to use shift as the Doppler velocity, and this is how the different three-dimensional vector works. A Doppler radar can only measure one of these three components and the motion along the beam towards the or away from the radar. The magnitude of Doppler shift decreases as the band of the transmitted frequency increase, and this is how the Doppler radar works. This is the Doppler radar, and this is also a Doppler radar, and we have to emphasize the phase determination between the Doppler frequency. Here the typical time period of the Doppler frequency is 1 by t, and the time duration is 1 microsecond. Now we have to understand how phase shift occurs due to the moving velocity of the target. We can see Vr is equal to lambda by 2 tr into theta 2 minus theta 1 by 2 pi, where theta 1 and theta 2 are initial velocities, and we can also see the Doppler frequency sampled pulse. And the main problem here is that the Doppler frequency can exist between finite and has infinite number of phase changes. So the finite pulses phase changes therefore are be less than a length of half wavelength, which is lambda by 2 tr, which is delta theta by 2 pi. This and Vmax is called the Nyquist velocity and represents the maximum or minimum radial velocity. A Doppler radar can measure unambiguous true velocities which are large and small values. And we can also see here the Doppler dilemma. A good choice of proof is to achieve a large unambiguous range to be pure and unambiguous velocity, and this is the Doppler dilemma. And the most applications are spectrum velocity and etc. And this is the main, and this is how the ranges, different correlation of ranges are formed, and this is, and we can also see here these are the different variations and the radiations of the torque, and this is the frequency, and frequency has time period and radiation of the pattern. And we can see the wavelength or velocity with respect to the wavelength, and the wavelength is c, and c is the constant velocity of x direction and constant velocity of y direction, and the wavelength with respect to frequency is to determine the velocity of the frequency and to start the general frequencies of the frequency. And here the different frequencies here observed are the observed frequency and the constant wave frequency from the source, and the source here is applied here, and since the change of frequency is with respect to velocity, then the change of is equal to change of source and observer. Then this is how we will get the velocity of the target.